In my previous videos, already we have studied about clocked SR flip-flop and clocked D flip-flop. So in this video, we will study about edge-triggered JK flip-flop, or also known as clocked JK flip-flop. So JK flip-flop can be derived from the SR flip-flop. So already we have studied the SR flip-flop. So this is the block diagram of SR flip-flop. Now I will explain how to derive JK flip-flop from SR flip-flop. Let this be a positive edge triggered JK flip-flop. So in positive edge triggering, we are supposed to indicate like this. This indicates this is positive edge triggered flip-flop. Let this be a clock signal. I will represent by variable CLK. So here we are supposed to use one AND gate. One of the input for this AND gate is Q bar output. Connect Q bar output of this SR flip-flop to the one of the input of AND gate, and another input for AND gate is J. Similarly here the output of this is connected to S input of SR flip-flop. Similarly for this AND gate, one of the input is from Q, that is Q output of SR is connected to one of the input of AND gate like this. Another input for AND gate is K input. Output of this is connected to R input of the SR flip-flop. So this is the complete block diagram of JK flip-flop. So this circuit represents SR flip-flop. This is my S input, this is R input, and this is clock input. Let this be Q and Q bar. So let me use one AND gate here. This is AND gate. Q bar output is connected to one of the input of AND gate. Similarly, Q output of this is connected to S input. Another input for this is J. Let me use one more AND gate here. Output of one of the input for this is from Q. Another input for this AND gate is say K. The output of AND gate is connected to R input of JK flip-flop. So this is the complete circuit diagram of positive edge triggered JK flip-flop. Now I will explain the analysis of this positive edge triggered JK flip-flop. Now let me analyze this circuit. So when clock input is 0, irrespective of J and K input, that is J value may be 0 or 1, K value may be 0 or 1. If present state of the flip-flop is 0, then next state will be same as the present state, that is 0. Therefore it is no change. Similarly, if clock is 0, both the inputs, irrespective of the input, if Qn is 1, in that case also next value will be same as previous one, that is 1. So it is no change. So as we know, in positive edge triggered flip-flops, the flip-flop is active only for the positive edges of the clock. Now let me consider positive edge. Positive edge is represented by up arrow. So now in all these cases flip-flop is active. So now let me consider the different values of J and K. Suppose J value is 0, K value is 0, and present state of the flip-flop value is 0. Let's see how the flip-flop will work now. Let me analyze this. So here I have taken, that is, let me consider case 1. So in first case I will consider J is equal to 0 and K is equal to 0, and we have assumed Qn is equal to 0. So Qn is nothing but present state of the flip-flop. I will assume Qn is equal to 0. So here Q is nothing but Qn. So I have taken Qn is equal to 0. When Qn is 0, Q bar, that is complement of this is Q bar, its value is 1. So this Q will appear here. We have taken J equal to 0 and K equal to 0. So this 0 will appear here, and here 1 will appear because this 1 will go here. So output of AND gate is now 0. Here also the output of AND gate is 0. So here we can see that S value is 0, R value is 0. So as we know in SR flip-flop, if S is 0 and R is 0, there is no change. There is no change means next state of the flip-flop will be same as previous state. So therefore now we can say that if J is equal to K is equal to 0, then output doesn't change. Therefore, now we can see that after applying clock pulse, the output Qn plus 1 will be same as previous one, that is 0 itself. Therefore, it is no change. Now let me consider J equal to 0, K equal to 0 and Qn is equal to 1. So here, now I will take Qn is equal to 1. Let me take it as 1 and let the complement of this will be 0 now. So now input for the AND gate, this will be 1. So input for this AND gate will be 0. So here J input is 0, K is 0, output of AND gate is 0. Here also output of AND gate is 0. So again S and R inputs are 0, 0. So output of the flip-flop we know that it is no change. So in this case also there is no change in the output. So therefore now I can say when it is 0, when Qn is 0, then Qn plus 1 will be same as Qn. So here Qn is, as we are considering initial value before applying the clock, that will be Qn. After applying the clock, will get updated output, that is nothing but Qn plus 1. So here also it is no change. So now let me consider the next case. If J is 0 and K is 1 and if Qn is 0. Let me consider this case. J is 0 and K is 1. That is, let me call case 2. If J is equal to 0 and K is equal to 1 and if we assume Qn equal to 0. So let me take J equal to 0 and K equal to 1. That is, here J equal to 0, K equal to 1. We have assumed Qn equal to 0. So let me take Qn equal to 0. If we take Qn equal to 0, Qn bar will be 1. So let me analyze. So this 1 will go to AND gate. So here it is 1 and this 0 will go to this AND gate. Here it will be 0. So now here we can see that the output of AND gate is 0. Here also the output of AND gate is 0. So again flip-flop will be in no change state because S and R are 0. So in SR flip-flop, if both the inputs are 0, there is no change. So output of the flip-flop will be same as previous one. That is, so Qn will become 0 and Qn bar will become 1. It means that flip-flop Qn is 0 means flip-flop will reset. So the output of this Qn plus 1 will be 0. It indicates flip-flop is reset. So suppose J is 0 and K is 1. If we consider present state of the flip-flop is 1. So let me take J equal to 0, K equal to 1 and Qn equal to 1. So if we take J equal to 0, K equal to 1, Qn equal to 1. So let me take Qn equal to 1. If Qn is equal to 1, then Q bar will be 0. So this 1 will go here. This is 1 now. And this 0 will appear here. So output of this AND gate is 0. Here the output of AND gate is 1. So now here we can observe that S is 0 and R is equal to 1. That is, in SR flip-flop, if S is 0 and R is 1, flip-flop will reset. It means that the next value of Qn will be 0. That indicates flip-flop is reset. So therefore, now we can say the flip-flop will be reset. The status will be reset. Will be 0. Therefore, the status will be reset. That is, here we can see that Qn plus 1 will be equal to 0. It means reset. Qn plus 1 is equal to 0. So now let me consider the next case. Suppose J is 1, K is 0 and Qn is 0. Let me take J input as 1, K input as 0 and Qn is equal to 0. So here I will consider next case, that is, I'll write here case 3. If J is equal to 1, K is equal to 0 and Qn is equal to 0. So I'll take Qn is equal to 0. So this will become 1. This 0 will appear here and this 1 will appear here. Here we have taken J equal to 1. Let me take it as 1 and this will be 0. So now output of this AND gate is 1. This will be 1. Output of this AND gate will be 0. So now here we can observe that S value is 1, R value is 0. That is, in SR flip-flop, if S is 1 and R is 0, the flip-flop will set. That is, Qn output will become 1. So Qn will become 1 means that is nothing but Qn plus 1. So here, therefore, Qn plus 1 is equal to 1. The flip-flop will set. So here Qn plus 1 will be 1. Therefore, flip-flop will be set. The status will be set. Now suppose J is 1, K is 0 and Qn is 1. We'll assume that present state of the flip-flop is 1. Let me consider this one. So I have taken, that is, if J is equal to 1, K is equal to 0 and Qn is equal to 1. Let's see. Let me take Qn is equal to 1. So this will become 0. So this 1 will go here. Input to the AND gate is 1 and this 0 will go here. So now output of this AND gate is 0. Here output of AND gate is is 0. So as we know, in SR flip-flop, if both the inputs are 0, then there is no change in the output. There is no change in the output means the previous output will be continued. So here previous output was 1. So Qn plus 1 will be 1. That is nothing but set. Flip-flop is set. So in this case also we'll get Qn plus 1 is equal to 1, which is nothing but set. Now let me consider the last case. Suppose J value is 1, K value is 0, K value is 1, both the inputs are 1, 1. If Qn is 0, that is, let me take next case, that is case 4. If J is equal to 1, K is equal to 1 and Qn is equal to 0. Let me take Qn is equal to 0. Therefore, Q bar will be 1. We have taken J equal to 1 and K equal to 1. So this 0 will appear here. This is 0 and this 1 will appear here. This is 1. The output of this AND gate will be 1. Here the output of AND gate will be 0. So as we know, in clocked SR flip-flop, if S is 1 and R is 0, flip-flop will set. So therefore, here we have taken Qn equal to 0. Therefore, Qn plus 1 will be equal to 1. That is, flip-flop will set. So therefore, here, if it is Qn is 0, then Qn plus 1 will be 1. Now let me take J equal to 1, K equal to 1. Suppose Qn is equal to 1. So here I'll take, if J is equal to 1, K is equal to 1, Qn is equal to 1. I'll take Qn is equal to 1 and this will become 0. So this 1 will appear here and this 0 will appear here. So now output of this AND gate is 0. Here output of AND gate is 1. So now S is equal to 0, R is equal to 1. It means in SR flip-flop, if S is 0, R is 1, flip-flop will reset. That is, next state of the output of flip-flop will be 0. Therefore, Qn plus 1 will be equal to 0. That is, here Qn plus 1 will be equal to 0. So here this state we will call it as if j is 1 and k is 1, there is toggle in the output, because the present state was 0, the next state will become 1. If present state is 1, next state will become 0. This state is known as toggling, that is toggle in both the case. This is nothing but toggle. So this is how edge triggered or clocked JK flip-flop will work. Now let me explain the operation of clocked JK flip-flop with waveforms. Let me consider the first signal. This is a clock signal. Let this be a J input. These are K input, and let this be Q output. So here let me consider positive edge triggering. This is the positive edge of the clock. This is positive edge. This is positive edge. This is positive edge, and this is positive edge. So flip-flop will be active only during positive edges of the clock. So let me consider the first edge of the clock. At the beginning, I will assume that Q input is 0. I will assume Q input is 0 at the beginning. When the first positive edge of the clock arrives, at this instant, J value is 0, K value is 0. When J is 0, K is 0, there is no change in the output. It means the same thing will be continued till next clock pulse. So this is the next clock pulse period. Till this, the same thing will continue. So now at this positive edge of the clock, J value is 1 here, K value is 0. So as we know here, when J is 1 and K is 0, if Qn is 0, then output Qn plus 1 will be equal to 1, that is set. So therefore, here the flip-flop will set, that is flip-flop output will go high, and it will remain high until the next clock signal. So this is high till this period. So at this instant, here we can see that at this edge J value is 0, K value is 1, and here Qn is 1. This is nothing but Qn, which is 1. So as we know, if J is 0 and K is 1, flip-flop will reset. Here we can see that when J is 0, K is 1 and Qn is 1, it will become 0, that is reset. So the flip-flop will reset. It means it will go low, and it will be low until the next clock signal. So it will be low until this clock signal. So at this positive edge of the clock, we have J equal to 1, K equal to 1. When J equal to 1 and K equal to 1, and here Qn is equal to 0. So here we can see when J equal to 1, K equal to 1, Qn equal to 0, next state will be 1. That is, here the flip-flop will set. It will change the state from 0 to 1. It will be high until the next clock signal. So here at this positive edge of the clock, J is 1, K is 1, but here we have Qn is equal to 1. When J is 1, K is 1 and Qn is equal to 1, J is 1, K is 1 and Qn is equal to 1, flip-flop will become 0. That is nothing but toggling. So here again the flip-flop will go 0. So thus here we can observe that when J is 1 and K is 1, flip-flop will keep on toggling. Now let me draw the Qn output, that is the Q bar output, which is complement of this. So at the beginning here it is 0, here it will be 1. That is nothing but high. So here it is 1, it will be 0 here, because it is complement of that. So it is 0 here, it will be 1 here. Here it is 1. Now I can make it as 0. Here it is 0, it will become 1. So this is the complete waveform for positive edge triggered JK flip-flop. This is how the JK flip-flop will work. So in short, the truth table of JK flip-flop can be written as, I will consider only positive edges of the clock. So when J is 0, K is 0. Here we can see that when J is 0, K is 0. That is J is 0, K is 0. So Qn plus 1 is same as Qn. It is 0, here it is 0, here it is 1, here it is 1. That is Qn plus 1 is same as Qn. So Qn plus 1 will be same as Qn, that is nothing but no change. When J is 0 and K is 1, So here we can observe J is 0, K is 1. Here also J is 0, K is 1. So this is the Qn. So Qn plus 1 in both the cases is 0, 0. It means flip-flop is reset. That is Qn plus 1 is 0, that is reset. Similarly, if J is 1, K is 0. So in these two cases, J is 1, K is 0. So here we can see that Qn plus 1 is equal to Qn plus 1 is equal to 1 in both the cases. Therefore, flip-flop is set. That is 1, which is nothing but set. When both are 1, 1, so when both are 1, 1, Qn plus 1 is opposite to this. That is complement of this. We can call it as toggle. So this is Qn bar. That is complement of that. It is called toggle.